Hello and welcome to this video. In this video, we will study Mergesort. Now, Mergesort is a stable sorting algorithm, and its runtime properties are similar to Quicksort. Typically, it sorts in big O of n log n. So let's see how this works. No, the only bad thing about Mergesort is that it requires extra memory to uh, perform the merging, and that is equal to the size of input array typically. And now this algorithm is given by John von Neumann. John von Neumann, who is also known as the father of modern computers. So we have our main.c here, the driver program. So we have the same array, and we simply call mergesort on a2 and -1. Now we have the header here, and we have the mergesort.c. So how it works is that you find the med element, okay? And now it is not simply L plus H by 2 because I want to avoid the overflow. Then you split that into two halves. The array is split into two halves. And then you go on repeatedly splitting the array into two halves. So you can imagine that if there is n elements, then splitting that will take log n time. Okay. Now, once the array is split, you start the merge process. So eventually, when you go on repetitively splitting, all the arrays will become of one element. So, for example, I'm not really. I'll do that later. Once the arrays are sorted, you merge them. So how the merge happens? So in case of merge, there will be three things. That is lower bound, middle, and higher bound. So to merge the arrays, we take three indexes I, j, k. We take n1 and m2. M1 is m minus l plus 1, and m2 is r minus m. We take two arrays to store the data temporarily, and in first array we copy from 0 to n1, and we put the value of a, the original array which we need to sort, varying from l to l plus n1. Okay. Now for the right hand side of the array, we store the value of m plus 1 to m plus 1 plus n2. So these are the values. Now if you see the bounds, the L will start at AL, okay, and then go up to L plus N1. Now what is N1? N1 is M minus L plus 1. So L plus N1 would be M plus 1. So that means it will start from L to M plus 1, okay, and then this starts from M plus 1 to M plus 1 plus n2. Now n2 is r minus m. So this will go from m plus 1 to r plus 1. So that's how it works out. So that's how you copy the two parts of the original array into two subarrays. Now once we have ijk, we set ij to 0 and k to l. And for I less than n1 and j less than n2, we copy the elements from the two subarrays to the original array, and it will terminate when I will be either n1 or j will be n2. Whichever is smaller, it will terminate then, and then either this while loop will come into picture or this while loop will come into picture, depending on whether n1 is less than n2 or not. And then we copy rest of the arrays. So let me try to resolve this, or rather show this how it works out. So suppose we have an array 4321. Now first it will be split into two parts, 4 and 3, and then the other part would be 2 and 1. Okay. once this splitting happens, 4, 3 will be split into two parts, 4 and 3, and then 2 and 1 will be split into two parts, 2 and 1. Now, when 4 and 3 will be merged, what will happen is our 4 will be in L array and 3 will be in right array. Okay, but if Li, now in this case, N1 and N2 both will be 1. Now, Li is less than equal to Rj. Is this the case? No. Okay, so in this case, what will happen is AK will take from the right part. Okay, that means when you merge 4 and 3, what will happen is you will get a 2 element array 3 and 4 when merging. The comparison happens, or the ordering of the elements happen while merging. Similarly, when you will merge 2 and 1, it will become 1 and 2. Okay, and when you will finally merge this, you will get 1, 2, 3, 4. So the actual ordering happens in the merge. This is the block where the actual ordering of the array is happening. All right, so that's it. Let's see this in action. We compile this, and that's what our sorted array is. The only downside of this Mergesort algorithm is this. Relatively, it is much simpler to understand than quicksort, and the runtimes are quite comparable. And the best property of Mergesort is that it is stable sort. So when you require stability, you should prefer Mergesort because quicksort is unstable in any case. And it is one of the most used sorting algorithms in general, just behind, I will say, quicksort in usefulness. So the typical way to pick an algorithm for sorting in general would be that when you want stability, you pick Mergesort, and when you don't want stability, you pick quicksort. So that's how you will typically pick a sorting algorithm. There are more advanced sorting algorithms which will follow after this. I will go through probably radix sort, and then I will put a hold on sorting algorithm, and we will study binary trees. When I will see about binary trees when we discuss them. So in my next video, I will discuss radix sort. And as always, if you want to study this algorithm in more detail, you can refer to Donald Knuth. He discusses sorting by merging in quite a bit of detail here. Okay, so you can see this that there are different variations of Mergesort are also given, and you can have some nice problems to solve as well in Donald Knuth. So I'll definitely recommend that you go through Donald Knuth's book for studying basic algorithms. That's it for this video. In my next video, we will study radix sort. So see you in the next video. If you have enjoyed this video and found it useful, please subscribe to the channel and like the video so that more students like you can benefit from this. Thanks a lot for watching. Happy programming. Enjoy.